Okay, let's see what happens what happens to pH during the course of a neutralization. So we can see what we've got in here is we've got hydrochloric acid, 0.1 mol per decimeter cubed. So the pH of that, hydrogen ion concentration is 0.1, so pH is going to be equal to 1. And what we're going to do is going to add sodium hydroxide to that. It's the same concentration, okay? Now, because these react in a 1-to-1 ratio, 1 mole of HCl reacting 1 NaOH, you can see what was the end point, let's say the equivalence point. The equivalence point would be at 25.0 centimeters cubed. That would be your end point of the titration, yeah? Now you can do this, and instead of using an indicator, you can put in there a pH. This is a pH meter. It'll give you a digital readout of the pH, and you can measure the pH. You can add it a centimeter cubed at a time. Right, so we would start off with the pH 1, and we know at 25 it would be pH 7, and if you carried on going past that, it would become alkaline. If you ask most people, and you say, well, what do you think the line would look like? They'd say, it'd be a straight line like that. And if you do the experiment, it doesn't look like that at all. It looks like this. Okay, so I will draw what it looks like. So it looks something like that. Okay, so at first, in this bit of the curve here, as you're adding the acid, before you get to the equivalence point, the pH just slowly creeps up, not much at all. And then when you get here, then all of a sudden the pH shoots up loads. Okay, and you will have experienced this when you've done a titration. You know that nothing much happens, and you add one drop, and the indicator changes color with one drop. Or if you're like with year 9s and you get them to use universal indicator, and you try and get them to neutralize some sodium hydroxide with HCl, it's very hard. It takes them ages to do it because they keep going way too alkaline up here, and then they add a bit more acid, they go way too acid, and it's really hard to get it green. And it's because it's very vertical there. Okay, and so what we need to be able to do is we need to be able to calculate what the pH is when we've added different amounts of acid. Now there's 2 points we know. We know the start, I've said that is pH 1. And we know here it is exactly pH 7. But all of the rest of the curve before you've added the equivalence point, so less than 25 centimeters cubed, we don't know what the pH is, and greater than 25 centimeters cubed, we don't know what the pH is there. We're going to now work out, do the working out for that. Okay, so what I'm going to do is I'm going to forget about, I'm just going to do the ionic version of that equation. So I'm just going to have H plus. Sorry, that's a bit over here. So we're going to have H plus and OH minus, and that's going to react to form water. And we're going to do our usual thing here. We're going to write down start moles, and then we're going to do final moles and final concentration. So let's do this. Say we've added, e.g., we're going to find the pH when you've added 5 centimeters cubed exactly of NaOH. Right, now how many moles do we start off with? The moles of H plus to start off with. Let's do that. Moles H plus, well, is equal to concentration times volume. The concentration is 0.1. The volume is 25 centimeters cubed, so that's 0.025. So it's going to be 2.5 times 10 to the minus 3 moles of H plus. Right, when we've added 5 centimeters cubed of NaOH, how many moles of that are we adding? Well, it's going to be concentration times volume. concentration is 0.1 and the volume is 0.005. So that's equal to 0.5 times 10 to the minus 3. I'll write it like that because then it's the same sort of way as the acid one. So we've got 0.5 times 10 to the minus 3. We're not worried about the moles of water. No, but let's see what happens after they've reacted. So some of the OH minus are all going to react with that. So they're going to go down to 0. Of course, they won't really go down to 0 because there's always a bit of OH minus in any solution. We know that, always a little bit of H plus. But that's going to go down to 2 times 10 to the minus 3. Now, the final concentration, well, we have to do concentration. Conc is equal to moles over volume, isn't it? Over volume. How many moles have we got? We've got 2 times 10 to the minus 3. Now, what's the volume? Well, we started off with 25 centimeters cubed, but we've added 5 to that. So it's 30 centimeters cubed, which is equal to 0.03 dm cubed. So that's over 0.03. So let's do that. That is equal to 0.067 recurring moles per decimeter cubed. Now we need to work out the pH of that. So we take a minus log of it, minus log of that. The answer is 1.17. So you can see it's hardly changed at all. It started off as 1, and we've added a fifth of the way to the end point, 25, and it's 1.17. So I'll just put that on the I'll put that on the graph. I'll put it up here. So we'll say at I'll do a little table here. We'll have vol of OH minus, and we'll have pH. So at naught, the pH was 1. When we added 5, it's 1.17. Now I'm going to go up to, let's go up to a much higher number. Let's do it for, let's change this. Let's say when we've added 20 centimeters cubed of NaOH. Let's change that to 20. Right, so I'm going to just mess around with these numbers here. So this time here, it's not going to be 0.5 moles of that. It's going to be 2 times 10 to the minus 3. We're going to have to subtract 2.5, take away that one to give us this number here. So that's going to be 0.5 times 10 to the minus 3. And the new volume, well, the new volume, let's get rid of this. The new volume in this case, well, we've added 20 plus 25. So that's going to be 45 centimeters cubed. So 0.045. So to work out the concentration here, we've got to divide this number by 0.045 moles over volume. Let's do that. 0.5 divided by 0.045. Sorry. The answer is 0.011 recurring, okay? Moles per decimeter cubed. Let's take a minus log of that to get the pH. pH is 1.95, so it's still very low, okay? So I'll just do it up here. Put that in there, so that was 20. And the pH has now gone up to 1.95, so it's still low. It's still about here, isn't it? Okay, let's 25. Let's put that in. We know what the value of that is. That's going to be that's pH 7.0. Okay, so you can see going from 20 to 25, you get a really big increase. Shall we do 24? I can't resist it. Let's do 20. What happens when you add 24? So you're only 1 centimeter cubed away from the end point. Let's change that. So 24. Or shall we do 24.5? That's even more exciting, even closer, yeah? So let's put in the numbers there. Right, OH minus, right, if you've added 24.5, that is going to be 2.45 times 10 to the minus 3 moles of OH minus. So that will react. How much is left over? You've got 0.05 times 10 to the minus 3 moles. What's the new volume? The new volume is 24.5 plus 25, that's 29.5 is equal to 0.0295. So to find out the concentration, you've got to divide that number by the volume, which is that. Is 1.69 times 10 to the minus 3 moles per decimeter cubed. Let's log it, minus log it to get the pH, 2.77. So even though you're only half a centimeter cubed away, well, I need to rub that out now, don't I? 24.5. That's 2.77. Right, now what we can do now is let's see what we need to calculate these some pHs when we in this region when we've gone past the endpoint, and that is a bit more tricky, and we need to use kW for that. So let's do that. Let's find the pH when we've added, cross this out. Let's say we've added let's just go 1 centimeter cubed over, so 26.0 centimeters cubed of NaOH. Okay, so do a bit of crossing out here. Not that bit. Okay, so 26, 2.6, that's the moles of NaOH we've added now. Right, that's all gone. This is different now. We've gone past that. We have now got 0.1 times 10 to the minus 3 moles of NaOH. Final concentration, well, we need to know the volume. The total volume now is 26 plus 25. That's 51 centimeters cubed, which is 0.051 dm cubed. So the final concentration, we've got to divide that by the volume. Let's do that. 0.1 minus 3 divided by, right, that is 1.96 times 10 to the minus 3 moles per decimeter cubed of OH minus. Okay, now we need to, we know the OH minus concentration. We know OH minus, but we want to work out the pH. So we need to use Kw, and Kw will take us 1 to the minus 14. That's the value at 298 Kelvin, isn't it? Strictly speaking, it's moles per squared decimeter to the minus 6. And let's just remind ourselves what's Kw equal to. OH minus times H plus. So H plus conc is equal to Kw over OH minus. So that's 1 times 10 to the minus 14 divided by 1.96 times 10 to the minus 3. So the H plus concentration is 5.102 times 10 to the minus 12. Let's do a minus log to get the pH. The pH is then going to be 11.29. Okay, so let's put that in our little chart here. So we've only gone 1 centimeter cubed past the endpoint. So there's 25 is the endpoint. It's 26, and it's gone all the way up to 11. 0.29, and that is there, of course, that's 7. Okay, now I could, so we're somewhere up here. Okay, we're somewhere up here, and I could carry on doing them, but I'm sure you can see how to do them yourself. And so if you wanted to, you could work out every point on that curve and plot it, and you would get this sigmoidal shape. That's typical of a titration, called the titration curve. And they do ask these questions occasionally on they won't necessarily even say it's a titration curve, but you'd be doing a titration. They say, well, work out the pH somewhere at some point before the endpoint. Or they might say, you've gone past the endpoint, you've got too much NaOH, work out the pH after the endpoint. Before the endpoint, it's always quite low, between 1 and 2. After the endpoint, it's always pretty high, 11.5 plus. And of course, the point at the endpoint itself, you get pH 7.